I'm Gavin. Welcome to Science with Me and We. Today we'll be exploring the myths of reactions between acids and metals. Let's head over to Lab with We.
Hey guys, this is Weemai the Science Guy. As you heard earlier, there is a myth that acids can be used to create a hole so that people like burglars can break in and steal valuable goods, or they can be used to help people flee and escape. But the question is this myth true? Take a look at this next video.
And some new video on 7 News at 11 showing, a man who was throwing acid on an ATM. Now, this security video is from about 2 weeks ago on the CU Boulder campus. The man is spraying that acid solution or dumping it on there. Then he comes back in a hazmat suit to check on the progress, see if it's going to let him in the ATM. Needless to say, the plan failed. Police didn't discover what happened, though, until a few days later when a student reported chemical burns from trying to use the ATM. It'll cost about $50,000 to replace that machine.
Now, we do think that acids will react with metals. However, unlike the man you saw earlier, we will test this hypothesis in a place where things are safe and sound. Now, before we enter the lab, let's refresh on some things.
Metals in a reactivity series are ranked based on whether or not a metal is able to overtake another in a single displacement reaction. This is crucial in the reaction with hydrochloric acid.
In general, the reaction with hydrochloric acid results in the hydrogen gas and the metal combined with the chloride ion from the hydrochloric acid. So for instance, let's have a solid form of magnesium. So magnesium reacts with the solution of hydrochloric acid to form magnesium chloride and the hydrogen gas. The following simulation will help illustrate this concept. Here's another example. Let's take lead and put it in hydrochloric acid. So we see the hydrogen ions gaining 2 electrons to become hydrogen gas, while the lead ions lose 2 electrons to become Pb2+ ions. Nitric acid is the other acid we'll be using. Nitric acid is a very strong oxidizing agent, and as an oxidizing agent, it reacts with the less reactive metals like copper. Now, let's head over to the lab. Today, the first acid we'll be working with is 12 molar hydrochloric acid, also known as muriatic acid. First metal we're going to test is iron. Now we're going to react hydrochloric acid with nickel.
Now we come to realize that nickel is towards the bottom of the reactivity series, so therefore it won't react with hydrochloric acid. See? No reaction.
And now zinc.
Would you look at that?
All that hydrogen gas. Now let's test copper.
Copper, of course, is non-reactive.
Let's test lead.
Now you do see that the lead is reacting with the hydrochloric just slightly. You can see the hydrogen bubbles starting to pop up.
And now our final metal, brass.
Now the brass does have zinc, however there is more carbon, so it's unreactive. First of all, thank you, Brianna, for putting that heart-shaped magnesium metal into a dissolution of hydrochloric acid. And second of all, magnesium is at the top of the reactivity series, so it will react readily with hydrochloric acid.
Well, now that's what you call amazing.
Now that we've tested the hydrochloric acid, we're going to do the same thing using 15 molar nitric acid. We'll use each of the same 8 metals and just put a small piece in about 10 milliliters of acid. Let's start with brass.
Here we see it's a greenish kind of color. Now it's starting to turn brown.
Instead of a hydrogen displacement reaction, the nitric acid is reacting with metal and forming a nitrogen gas. That's toxic. This is the reddish stuff.
So whatever you do, don't ever sniff it.
Now this is really common sense. Why would someone go up close and smell all this nitrogen gas? So, just a warning, do not smell the gas.
Okay, now we're going to do the same thing with iron.
Yay, fun stuff.
Okay, next metal will be lead.
Also fun stuff.
Now we're using nickel.
Also fun stuff, except it's kind of changing color there.
It's a slight change in color. Now the nickel is turning green.
Very, very lime green.
For now, let's move on to copper.
Oh, now we see we're starting to change color. Here we see the same nitrogen gas coming out. This is very similar to the reaction to brass.
Now that time, as the cameraman got kind of stupid and kind of went up close before the reaction kind of started going active. So that was a really close call.
Is the AP bio in the same part? I'm taking AP bio.
Okay. While we wait for the gas to clear, now we're going to go ahead and test aluminum. Aluminium.
No reaction. Very little.
Again, it doesn't react very much. And finally, zinc. This is a much stronger reaction. I'm going to put this.
Very recommended that you do.
So yeah.
It was not 2-3 minutes. I was in the hallway and it was like 3:20. I'm not gonna. That's 10 minutes. Okay. I get literally done takes like 5 minutes to change.
So we see that about, say, maybe 3 of these metals had little to none reaction with nitric acid. So very, very reactive and very smelly too.
Get the phone up and read it.
Last, we're going to try magnesium.
This reaction definitely deserves a nomination for Best Reaction of the Day. So, was our myth busted or proven? Well, some would say that it was busted because of metals like nickel that didn't react with hydrochloric acid nor nitric acid. However, from the data that we've taken, we would say that our myth was proven. With the metals that we tested today, they reacted with either one or two of the acids that we tested. Now, could we have tested this with sulfuric acid? Well, sure. We could have tested this with 18 molar sulfuric acid, but we felt like hydrochloric and nitric acid was enough. Now, were there possible errors? Well, yeah. The reactions probably didn't go long enough, but we still could say that it's good enough to conclude that acids do react with metals.
I'm We Mind Science Guy.
And I'm just Gavin. Thanks for joining us this week. Tune in next week to see thermite reactions.